Right. Well, this is an accessor for a DescriptorPool handle. But we're not allowed to use the pool handle that is being returned unless we are the only thread doing so. Now the pool itself is protected by read-write. Mutex, I think. No, it's primitive. Just a simple mutex. But yeah, this is just locked in order to get the handle, and then the handle is returned. That's not how it should work. I think a correct way would be to return an object that maybe I don't want to lock it too soon. So it would be nice if I had an object that could pass, which then ticks the lock at the moment that it is used and releases it at the moment that it isn't needed anymore to lock it. But yeah, that would be the VkDescriptorPool object itself, I guess. You can just return a no. The const reference would not allow me to write log it, but maybe that's not even necessary. It is only read logs here anyway. So let's do that. I'm going to return const reference to the DescriptorPool itself, making this just an accessor. And that should break things sufficiently to know where I have to make the other changes to make it work again. For example here, that's passing that thing to the allocated descriptor sets. So then this becomes a DescriptorPool. As a type. I think so. Yep. But that is an private member of a logical device. So probably should make it public then. Or not. If I keep it private, it's kind of funny, I think. Then I can still pass this without knowing the type if I just pass the function that is returning it. So it might not even be needed to make it public. It's kind of weird though that I would pass anything to a logical device memo function and then having to pass something that a logical device just returned. It seems to be maybe be more logical to just not pass anything and always use the same descriptor. Okay, now I have to make take the log here. Let me just take the log, I guess, like this. Read access type, DescriptorPool, or created from this DescriptorPool. I'm not sure if I am allowed to set the debug name on it, but since it's only debug code, let's just wait with the unlocking of the mutex until the end of the function. Now here's something that is equivalent, so I'll just fix that immediately as well. So then here I take I lock the mutex by creating this object. That gives me read access. And it remains locked until this object is destructed, which then happens at the end of the function. I don't know. Let's just see where I get compile errors again. Allocate descriptor sets. Hi, this is a neo-vim, nvim. Damn it, I did not mean that. I meant allocate. Yeah, I just started. Expect to go over 100 views. It seems to be happening every day. Oh, yeah, that wasn't smart. Well, I'll just use my mouse, I guess. Right. The color scheme. Well, it's new Vim. And the color scheme is something I made myself. Well, syntax highlighting stuff. And you can find that on GitHub. Have a look at that. It comes with the README and everything. So, and then yeah, you see same colors. No matching constructor for initialization of the descriptor pool type red. Yeah, that's correct. I'm passing a const, so I need to use cred. Thank you, Mr. Russian, I think. I cannot pronounce your name. Yeah, before anyone asks, so I've been coding pretty obsessively, I think, for the last 28 years in C++. As you can see, every day of the week. There's no difference for me. Saturday and Sunday included. So I'm not saying that my methods are the holy grail. Absolutely not. I know a lot of C++ programmers on the internet that frown heavily upon what I'm doing. But well, I think that yeah, if you watch me work like this every day for hours, you're gonna pick up something, some good habits. Probably. Maybe not in the most efficient way, but if you come from nothing, then well. And now I've got the error. What was the error? It doesn't know this. Yeah, that's right. So I just compile error as a result of me changing stuff. So instead of passing the vulkan handle, I now pass const reference to the read access type. Yeah, it's a good question, man. What is the engine for? I try not to think about it too much. First have to finish it. So it's more of the same, I guess. Well, I never used. I mean, I think it was Microsoft that started with the IDE stuff, and I hated Microsoft. I don't think I ever ran Windows. I started with yeah, all kinds of things. And at some point, I think around the Linux kernel 0.99 something, I started to use Linux. But hey, it compiles. So apparently the problem should be fixed now. That the two threads are using the same descriptor pool at the same time. But we'll never know for sure, because it's probably a very rare error. That's too unclear. Let me just run it here. Core dumped. Why? Where? Okay, because of this, I guess. Now previously I scrolled up and I saw another validation error that was about the simultaneous, and yeah, it's not there now, but how often would that happen, right? I'm just going to assume that it is fixed. So let's now work on the first part of the description of this stream. I added the description and I don't know if you read it, but it said the second part was also I ran into a validation error stating that I'm using a VkDescriptorPool handle concurrently. That's the first thing I'll be working on this stream. So I just did that. The first part says working on splitting preprocess up into two parts. It should allow me to find out if the pipeline layout that I need already exists. If it does figure out the correct and if it does figure out the correct set indexes and binding numbers that I should use in order to make the layout, in order to match the layout that is already in the cache before generating the glsl declarations and compiling the shaders. I did already work on that off stream, I have to admit. So you can see it in the git diff. So before this code, before will mean what I deleted and not the green stuff, right? This was old code, so that is deleted, and this is new code that is added. So if you look only at the red stuff, you see I was just calling build shadow. Build shadow then begins with pre-processing the code and then compiling it. But I want to split it. But not for this one, because this is a triangle at the moment. It's not very difficult. But the split you can already see. What I do is I first create the declaration context for each shader by calling this split off part of preprocess, which currently I call preprocess 1. I probably should rename it to, I don't know, generate declaration context or something like that. And then having the declaration context, well, I just pass those to the build shader. And the same thing here, slightly different. First calling preprocess, and then the result, which are the declaration context, they are now passed to build shader. So also here, not really any difference with the old code. just that this part is now just split off and becomes visible here. Those two applications work. I've already tested it. Still work, I should say. Well, this is what we just worked on. To change it from passing a Vulkan handle to just passing the whole thread safe pool, so we can lock it inside that. Same thing. Okay, this is definitely different. That is the one that I just did run and it crashed. So we're going to make this one work. So previously it was also simply calling build shader for the vertex shader and the fragment shader. And now I'm only doing the pre-processing. So this is just removed. We do not even have a compiler anymore. And then I just run over both the two shaders. And I'm calling preprocess only. So this code is wrong because I need to remember what is being returned. It's not hard to understand why I get a validation error, because I'm not even compiling the shaders anymore. And here's another case. Also, instead of calling build shader the way it was, I'm just calling build shader and passing whatever declaration contexts are being returned by the preprocess, which must be passed to build shader. And the rest is that descriptorPool stuff. Okay, I also replaced the standard map type with a wrapper. It's a new class that just wraps a map. I did that yesterday. It's still in the div. And here you see what the preprocess 1 is doing. Basically it's doing the same as preprocess before, but I stop sooner. It is getting the declaration contexts. If the declaration context is a map, I guess. It's a set. Yeah, it's a set, so a container. And here I add new stuff to it. Which then we run over, so all the context. And then if it is a shader resource declaration context, then I call generate 1 on it. So the second part of preprocess is now called preprocess 2. And that gets simply past this set of declaration context that we created in preprocess 1. And then it picks up from there. So it generates the declarations still. It used to be here. Code just moved up. And then it does the same loop, but without what we already did in preprocess 1. Namely, it's finding all the positions where those strings occur that we must replace. And that continues with the actual preprocessing, which is not even shown in the diff, where those strings are replaced with whatever they have to be replaced with. And the declarations are added to it. Okay, that was hard to get through, but maybe now you have a little bit of a very fake idea. I'll repeat it when we get to it, but the point is that we did a step backwards. I'm no longer compiling the shaders for this particular application, the uniform buffer test application. Seems I only have, I have using tabs these days, since today actually, or since yesterday, well, I don't know, since I last rebooted. So before we had a compiler here, and we did. We compiled the shaders, which generated the declarations and did the pre-processing of the glsl template code, and then compiled it. And now I don't. The reason I don't is because what I want to do first is it's not even done in this function. Let me think about if, so, yeah, can we do what I'm doing here that and leave the function without having the, without having compiled the shaders? I think so, but I'm definitely going to need to remember whatever this is returning, because that's my declaration context. I'm not sure where to store it. It might be enough to just store it in the same class somewhere here, but I'm not sure. So I'm going to look at where this function is being called from, which is I think pipeline factory. Yeah, there. It's being called on whatever m characteristics I is. That's the object. And that, well, that is a member of whatever this class is. So we should still have that a bit lower. Namely, when this is being called. No, even lower, I think. It's not entirely clear. I think that the point is I can create a pipeline layout without... Can I? I'm not sure. I want to say without the compiling shaders. Yeah, you can. You can. So I would say that it should just simply work up till and including that it calls this function already, and it should print my binding map, which I'm very curious how that looks like. But also I don't see any problem with storing the declaration contexts in this object, because well, we also have them here still. It is very close to that line that I think is where, well, shortly thereafter I can compile, so then I will need it. I'm just going to start with storing it in that function. Which was, I forgot. Oh, here. Oh, well, this is a custom. This is a custom type. And these M characteristics are characteristic range pointers. So that's a base class of this thing. I mean, the characteristic is derived from characteristic range. Yeah, or yeah, you have to run gvim maybe. I hate it. It's that, say, if you paste something with a mouse, I wanted to paste it where my cursor is, and all those editors that move the cursor to where you click and then paste it there, that's horrible. So I definitely have deliberately no interaction with my mouse. I can just copy and paste, but it's not going to move the cursor because of my mouse. So I had to add it to characteristic range, and it turns out that characteristic range currently owns the shader input data, although with a fix me. But I would rather add it to the shader input data, if possible. So each characteristic range has a shader input data object. Even more beautiful, the shader input data has Hmm. I thought that this was defining the type of the container. No, I'm not sure anymore. Well, I was looking up there between all the other type dev usings, but it's declared here all the way down. But yeah, so the shader input data itself declares this type. And now I wanted to even add the container here. So I am going to move it up. Well, it probably needs to still be public, I think. If I make it private, I'm sure I'm going to get problems. But let me test that. Well, let's not add it to the push constants. It's a shader resource thing, so let me try to define it here, which is private, and see if indeed it doesn't compile anymore then. Well, I believe I'm being pleasantly surprised that it does still compile. So then let's add a container here. And we're going to need a container per fragment, no, sorry, per stage. That is maybe slightly annoying. Or per, I had this M characteristics thing, which used I as an index. I could make a new index type. Let's leave this like this, because it doesn't compile, so I'll find it back. So I had M characteristics. Well, if people are paying attention, what you see me do is be distracted between quotes continuously. I'm doing something, and then in the middle I stop and I start to do something else. And then I stop in the middle of that and I start to do something else. And so on. I think that's very typical. Yeah, you just should not be afraid to get distracted by something else. Just as long as you're working and typing and you have progress. Although it does help if you have a good memory and you can remember exactly what you were doing, the whole tree. And then once you finally finish some branch of the tree, and you can go back to where you were at the moment that you got distracted into that branch. So my idea was that I wanted to store it in this, but it depends on the eye. So what is it? M characteristics is simply a vector. Now why wouldn't I make a new type for characteristics, a characteristic range index, so to say? The nice thing of that is that then I cannot get confused with other indices. If you use an int for everything, then in the end you have a billion vectors and they all use the same type for their indexes. And then if you have multiple vectors that use the same type of index, which means that if you use an index in one of the vectors, then what you get is an element that is actually corresponding to an element of another vector if you use the same index. But it gets confusing very fast, unless you use my method of vectors that use specific indexes. So I think I want to do that. Now that index is probably simply related to characteristic range, so let's invent it as a function, or let add it here. Oh, what is this? Index. This is already an index. Index category. Index of what? What the hell is this index used for? It's a very vague name. Oh, apparently we already have it. It just had a clumsy name. Just index. This looks like a pipeline index. It's inside the namespace pipeline. Here it is called pipeline index. Now that index is used for pipelines, so it's not a characteristic index. I'll have to use I'll have to make another one, I guess. No, it was not that one. Okay, new index has been born. So now I want that to be used for m characteristic. I can just change this to utils vector. Now this stores a boost intrusive pointer to that thing, so I'll just have to explicitly add the characteristic index, which is defined in namespace pipeline, and currently we are in namespace task. So namespace unknown, vulkan pipeline. Okay, already including that for that. Now there is a chance that there are more vectors than just m characteristics. Let's try to find those. So I can do a grab project sources for yeah, standard vector. I never use using whatever, so it's always standard vector. Followed by something with a characteristic. No, just two mismatches on two comments. So that should have been the only one. And let's look again for m characteristics. So I made it a different type now, utils vector, and apparently it's only being used in the .cxx file. Start at the top of the file. Yeah, pushback. Well, pushback is still going to work. It's nothing to do with an index. Not empty, idem dito. This is different. I can no longer be an int, because int will not work anymore. So instead I have to do auto, something like that. M characteristic begin. But now I added something to vector, the capital. It's called I begin. And then we do the same thing here as you usually do. I end. So this it looks almost like an iterator, but now it's an index of a certain type, which can be used as an index. Yeah. You cannot even pass 0. If you pass 0, then yeah, that's an int, so that won't work. We'll have to do I have to just create it. Why does it stay red? Characteristic index. I don't know why it is red. Looks fine to me. Alternatively, I suppose we can just use an iterator. Maybe that looks cleaner, especially with the red stuff. So I just want to have begin. It's shorter as well. So begin returns an iterator to the first element, and then the arrow dereferences it. So we get pointer access to the first element, and the first element is a intrusive pointer. It's not working. It's not working. The characteristic range has a I begin also. Seems I have to dereference it. So now I have the first iterate to the first element and then dereference it, and that's the same as if you pass the square bracket 0. And that then is an intrusive pointer, so then you can add the pointer operator. Use the pointer operator on the intrusive pointer. And here we're using square brackets again, and now on M range counters. That's a multi-loop. Ouch. Yeah, I'll just have to cast that. Now we have to cast it anyway. Characteristic index. A multi-loop is allows me to make nested for loops that are, the number of for loops is dynamic. And it is one of the hardest things to use that I ever wrote, even though it's super simple. So usually when I see a multi-loop being used, then it's like, don't touch this code. It's all kind of, it's more like an incantation. You just have to do this, and then this, and then this, and then this, and then cross your fingers that the recipe that you used was correct, and that now you have multiple nested for loops. But yeah, multi-loop is simply returning an int, I think. I can even check that, or size type maybe. It's definitely working with ints. So yeah, unsigned int returned by operator star. And here's the operator star. So this returns an unsigned int, and then I have to cast that to my characteristics index. Which is not highlighted. Why not? What am I doing wrong? I call that range for obvious reasons. Did I make that mistake another time? Nope. So yeah, that's just a vector index which we can construct explicitly from a size type. Yeah, is that going to work from a unsigned int or not? We'll see, I guess. Okay, here the same thing. This is again a for loop, so that's the same as up here. I think I have beepies in the background. Well, this would only work if mRange counters is also. Oh, that's sorry, that's not what it seemed. At the top. So this is the last one then, and also needs a cast. I'll be right back. I'm going to make the beep stop. Ja. Het huishouden is een bitch. Characteristics. Non-friend clause. Mem vector cannot have a qualified name. Excuse me? Non-friend clause. Oh yeah, that. So now I can do utils vector of these things using pipeline characteristic range index as an index. Let's call these things declaration contexts. Oh, this is already plural. So we'll call it per characteristic range declaration context. Error. No member named characteristic range index and namespace vulkan pipeline. I don't like including headers. Well, it's not necessary. The thing is not even including pipelines at all. It is inside pipeline itself. Share the input data. It's not a good thing, right? In shader input data.h, it says that it doesn't know what shader input data is. In other words, this did cause a circular buffer dependency, a circular header dependency, which means that I'm just not going to include it. I did that in here. Characteristic range. Oh. Yeah, missing braces. Missing parentheses, I mean. Nope, still has a problem. Amp characteristics is apparently not a pointer. No, it's not. It's not a pointer. I don't think I use Vim plugins. Well, not a lot anyway. Let's see. Where is that? In config. I use the ANSI escape plugin so that I can see the colors. Now maybe there's something in plugged. Clang format, which I never use. Vim box draw, which I never use anymore. I don't even know what the other things do. So I don't think I use really use any of these. But use of undeclared identifier pipeline. Did you mean vulkan pipeline? I mean the syntax highlight colors work, but that's using term IO stuff. But I use the ANSI colors when I print debug output. Now if I write my debug up to a file and I open that file, you still don't see the colors, but I don't know why. I think it used to work, so I don't know. I'll go back to int when I pass it to get value returns from my vector index back to an int, which is necessary if I pass it to mRange counters, a multi-loop. Slightly worried that this is all for nothing. Because I still have to figure out what those indexes are, right? What are those indexes? So now I'm calling preprocess 1 on mShader input, and the result I want to be stored in mShader input data, right? So shader input data now has this set, not this set. This vector here. Ah, right, I know it. I just pass it to initialize, and then I know the index. Evil laughter. Yeah, so the idea is that I'm just getting here Vulkan pipeline characteristic range index being passed. And mystery of the magically. But yeah, why would I store the returned value? Why not just let preprocess store it? Which then means that I need to pass it here as well. Let's pass it on to preprocess 1. As a second argument. And then instead of having a local vector here, okay, it's slightly more complex, but the idea is that I'm getting a reference here now, which we steal from our new vector, which I guess is called m underscore something, and that should be probably, what was it, per characteristic range declaration contexts. So this is the, yeah, for every characteristic range I have I have declaration contexts. So if I then give that the characteristic range, then I get back declaration context. And there is no good reason that I see to pass it, to return it. I'm just going to store it in the objects. There is just one problem here. The vector might not be large enough, and I'm using this index here, so I need to make sure that this thing is resized at the same time the m characteristics is being resized, which I have no idea when that happens. But let's try to figure that out. All other things that I have to change now, because I did not make all necessary changes, all other things will give compile errors, so I can just forget about them. But I cannot forget about the fact that here's a pushback, empty, begin, and probably the pushback is being called yeah, way before this runs, so the size is kind of fixed. And I just need to have that size of the other vector be correct before I call initialize, which means we can do it here. So that thing must be resized to the same size as this thing. I don't want to throw anything away or whatever. I mean, I did just totally expect it to be empty, right? This is the first time we're going to use it. So this must be empty as well. And I'm resizing it to the correct size here. So give and the right size. But that thing was stored in this doesn't make any sense whatsoever. I'm doing something horribly wrong. But what? Sorry guys, I have to think. How the hell? Shit. Yeah, totally nonsense. Horrible. Damn it. I got two things confused. I want to undo the last half hour. It is not easy. Could also keep it, but the characteristic range index is not necessary. Can still keep it, but well. Okay. Yeah, so now we are back where we were, except that I did make a change. Let me think. Yeah. So we get here, the pipeline factory was initialized. This thing is empty. You run over all the characteristics, of which we have 2 in this case. And then we call initialize on them. Which we'll call preprocess twice. Once for the vertex shader and once for the fragment shader. And the resulting declaration context of those 2 shaders is then stored in mCharacteristics I. So in total we store four of them, because we loop twice here, and then we have 2 stages. I'll fix that some other time, I guess, because I still don't know. Okay, after initialization, we are going to run the pipeline factory generate stage of this task, which does a difficult thing with nested for loops. Runs again over all the characteristics. And calls fill on them. I don't think that in this test case fill is doing anything. Let's find the fill that is being used. I guess this one, it's just empty. Yeah, I'm not using a range. I'm using a characteristic, no range. Even though it's derived from a range. And the characteristic that is not really a range is as a fill that does nothing. And update also doesn't do anything, I think, for this test case. See, this is characteristic range update. Oh, it does do something. I guess it keeps track of something. It's some internal function. Yeah, well, whatever. Calculate pipeline index, apparently. Now we are going to create the pipeline, or the pipeline layout. So we extract all the information from our flat create info that has all the information. And then we execute this. Yeah, I guess we cannot get through this, or can we? I'm not sure. I think I said before that we should be able to create a pipeline layout without compiling the shaders. So this should all just work. And then it should print set binding map. And after that, I can finally compile the shaders. And then I have the feeling that it should work. The application should actually work. I want to see this output. I'm trying to create 2 pipelines, so we should get here twice, I think. Yeah. Zero times. And yes, I want my colors back. Why are there no colors here? These are the color codes, although now it seems that my escape has been turned into 2 characters. I think I just turned it off now. And now I turn it on, but we don't see colors. Why? Unacceptable. I don't see it. Well, I guess the question is, why am I not getting at that point? Not even seeing a core dump in this file. I run into a validation now. I'm just going to run it in the debugger again. GBT, GDB. Okay. That's a trap point, so I just printed it. We can go up into the validation layers and then it should end up in the actual function call, the vulkan function call, which is here. And I can go one more up and then I'm going. Now we are at the point where my code is calling something and which causes a validation error. I set the font small on this one, right? It really, it's easier for me, but I'll make the font like this. Otherwise it is unreadable for you guys, I think. So this is where we are. That just printed update descriptor set. All right. Threple 1 enters this function. Yeah, the problem is that the binding number is swapped. But we have a descriptor set that whose layout uses binding 0 for the combined image sample. And what? It looks like there's a lot of information missing, which is, I'm afraid, because I switched profiles. I have to switch back for a second to see what it is about. Okay, now I'll just run it again. So I'll switch to the profile YouTube, quit. Yes. That's better. Yeah, I was missing the binding 1. So binding 0 is the combined image sampler. And then binding 1 is the uniform buffer. And usually this is the other way around. And that's why it is barfing on this. So it repeats, binding 0 is a combined image sampler, but update type is a uniform buffer. And that happens as a result of this call here. It ain't not very clear. I'm going to up. There we are. Well, it's even better to go one more up, I think. Yes. Yeah, I'm trying to update the top descriptor set with uniform buffer at binding 0. Where the binding is a hard-coded line above this. Control that list. Just set binding at 0 here. Normally it is 0, but apparently in this case this descriptor set has a layout with binding 1 and 0 swapped. So it's wrong. It should be something else. So the hard code is just wrong. Wrong. How could I know that? Could I know that? Yes, I could know that. But could I know that at this point? I don't think so. This is create uniform buffers, which is being called at the end of initialize. We cannot do that. I think that this is a direct result of the fact that I already realized my descriptor set layouts. That kind of also has implications for the set binding map. But I don't need something like compiling, or do I? Well, yes, of course. If the bindings change, then I need to compile, but I haven't compiled yet, so... But apparently I do need to know what the bindings are. Let me have a look at this function here. Realize descriptor set layouts. Doesn't even look anything up in a cache. What is that? Returns a set index hint. Yeah, okay, well, whatever. What does it do? Because this is the function here, realize handle. Realize handle calls try and place a descriptor set layout. Yep. This does a lookup. This find here. And it looks a lot like the other function that looks up the pipeline layout in a cache. And that function has a set binding translation map. I'll just have to add that code to this one as well. What am I doing? I'm coding, programming. And yes, I'm using Vim. Thank you, Bloodthirst. Yeah, Super Crump. I am sorting my descriptors because that way I can compare the whole, as it were, with other times that I created descriptors. And then find back the cases where I already have created them. So the sorter that you see here is just an attempt to make them canonical. No, unfortunately I do not know Python. bindings. I'm thinking about whether or not to delay the creation of the descriptor layout, descriptor set layout, or that I should create them here, but then also use a mapping of the bindings when I find them back in the cache. Okay, I'm gonna do an explanation. The problem is as follows. Yeah, I have certain inputs. Let's say a stage. So a stage is a vertex. That's a pipeline stage, right? So vertex or fragment are two stages of the pipeline. I also have the shader resources. For example, a uniform buffer, or a combined image sampler, so that's called texture. So the texture is only used in the fragment shader, and uniform buffer in this case is only used in the vertex shader. Now I can even have multiple of those. So say my vertex shader uses uniform buffer 1 and 2. And the fragment shader uses a texture. Each uniform buffer is just a method to write data from my CPU to my GPU. And could be, say, some kind of struct. I have a struct A with some data. Say a float X and a float Y, and I want to transfer those from my CPU to the GPU. Then this is just in total 8 bytes, and I make a uniform buffer that has a size of 8 bytes. And I write my struct into the buffer, transfer the buffer to the GPU. And then in the shader I decode it again, and I can read those values X and Y. But clearly uniform buffer 1 and uniform buffer 2 can be completely different. They can have different sizes, they use a different struct, they have a different meaning. Now suppose I am creating a pipeline with these stages, and that pipeline is using those uniform buffers. And this texture here. And then later on I try to create another pipeline, and that pipeline uses the exact same uniform buffers and texture. Then the layout of the pipeline is the same. So I do not want to create another layout. I want to reuse the same layout. You have to create layouts, have a handle and stuff. But each of these shader resources need to be assigned a number, 2 numbers actually. Namely a set and a binding within that set. For example, I could make set number 0 contain uniform buffer 1 and the texture. And set number 1 could contain just the remaining thing, number 2. And then this could be binding 0. Let's call that B0, B number 0. And this is then binding number 1, because they are, what is the word? Consecutive. You must start at 0, so this is just one element, so it must be 0. Well, this is just one option. And the numbering is not relevant for the layout. Not really, because if I call this 1 and this 0, I mean, yeah, no, it's really, it doesn't really matter. It's still the same layout. But I need to know what those numbers are, especially because they are hard-coded in the declarations of the shader. I mean, the vertex shader must know about these uniform buffers that it's going to read. So it has declarations. So I have a vertex shader in this case. The code contains something like layout set is 0, binding is 0, and then uniform. And yeah, more stuff. So now we know that this uniform buffer, in the end we have a variable name, let's call that uniform buffer 1. It's not exactly working like this, but that's the idea. So now my uniform buffer, it has hard-coded the 0, 0.0, so that's 0, 0, uniform buffer 1, right? And the same shader also has needs a uniform buffer 2, so it also needs a declaration for uniform buffer 2. So it also has a 2 here with a set of 1. Oops. So set number 1, binding 0. That was that one. Now what I did before was I didn't look further than this, and I just say, okay, well, I suck this out of my thumb. Let's use 0 and 1 here, and 0 and 1 like that. And then I generate the declaration and I compile my compile the shaders. But then afterwards I create something that is basically the same layout. Well, basically exactly the same layout. So let me make a copy. We're going to create a new pipeline. So this is an exact copy. And the layout is the same because the top is the same here. So this highlight, oops. This highlighted part here is the same as above. Therefore the layout is the same. But the initial set values are random. I have absolutely no reason to pick one number over another. It's kind of you never know what happens. So it could be that these things are swapped and that these two are also swapped. I mean, the 0 and the 1 have both to exist. To make it more clear, I'll put this up front. So we have a 0 and we have a 1. And in total we have a texture in a some set. In this, I don't know which set, but there is a set that has a texture and a uniform buffer 1. And there is a set that has a uniform buffer 2. Just the numbers are different. This is still the same layout. So what happens now is that first I want to create a layout of set number 1. And I do that by not by passing those binding numbers, because they are not interesting. I'm only saying, okay, I have a texture and I have uniform buffer 1. Do you know that? And it goes looking in the cache and it says, yes, I have that here. So it already exists. And it passes me a handle to this layout, descriptor layout. It's a descriptor set. There is a descriptor set that has that layout. And that's what it returns to me. And then the next code says, okay, now I want to update it. I want to really link the descriptor set to these resources. And then I say, okay, please, binding number 1 is a uniform buffer. Update it. And then it says validation error, because the uniform buffer is at binding 0, is not at binding 1. So that's what currently goes wrong. Now, code that I already wrote, which happened later, suppose that the bindings were not swapped. So they were still the same as there. I'm going to delete it. If the bindings are not swapped, it would not complain. It would just say, okay, you want to bind uniform buffer to 0. That's okay, because that's what it was. But the set numbers, the set indexes are still swapped, as you can see. So later, I want to create a layout of the pipeline itself, and that encompasses everything. And then the same thing happens. I try to create a pipeline layout, and it will say, I already have that. Now it takes everything into account. So it says I have a set with uniform buffer 2, and I have a set with uniform buffer 2 and a texture. Well, I already have that. So it's going to return this layout. And then what I do is, okay, I get that, but I thought the set was 0. So what it does is it's going to tell me, yes, I have it. But then you have to translate set into set 0 into 1 and 1 into 0. That's a mapping. So what I do is, okay, I thought it was this, but I didn't use it yet. And now I'm going to regenerate it. And I'm going to making this 1 and this 0, because that's what it should be. And then I generate this as the declarations. And then I compile that. Or that isn't even necessary, I think. Yes, it is. Because the rest of the shader could be different. Something went wrong, because in the end it has to be the same as what it was here, of course. I copied it but didn't change it yet. So it was exactly the other way around. I expected it to be this, but then I had to change the sets because of the mapping was different, and then we get the same declarations as I used here, possibly with a different shader, so the code that comes below the declarations. But at least that would work, because now layout is the same, and I use the same handle to the pipeline layout, and after this translation it just works. However, and now comes the problem that I'm facing right now. Suppose the binding is different as well. So if the binding is different, it's different anyway. So let's say we started with this. If I delay the update of the binding, where I get my validation now, and I simply yeah, I simply don't do that. And then I go look up the pipeline layout in my cache, and I find it, I will get the complete mapping change. So I thought it would have to be, well, let's see. So this is uniform buffer is 0, 0, it's uniform buffer 2. And uniform buffer 1 is set 1 binding 1. And so this set 1 binding 1 is uniform buffer 1. And then we have layout set to 1 binding 0 is a texture. This is what I think it should be, but what I used before, the declarations that I used before were like this. And now the texture is at binding 1 of set 0. So this is what I should end up with. Well, if I say, okay, look up for me if you have a pipeline layout that has these sets and binding numbers, and it says yes, I do, but then you will have to change the following: set 0, 0 must be changed to, and it's going to map it. 0, 0 must be changed to uniform buffer 2, so this is 1, 0. And uniform buffer 1, so 1, 1 must be changed to 0, 0. And the texture, that is 1, 0, must be changed to texture is at 0, 1. So I get this mapping back. I'll apply this mapping to these numbers, both set and binding, and I'll get that declaration, and then everything is fine. And then after that, I can also do the update, because now I have the right binding numbers. So that would work, but is slightly more work. So I'm wondering if it is possible to do the binding translation already here. So at this moment, just this line here, the very line, I look up the descriptor set layout, and I find in the cache this one. Now that it is set number 0 does not matter. So we find that one, and it's not really important what the set is. I don't care, but I do see that uniform buffer 1 now has a different binding and texture as well. So this could succeed in the same way as what I have here, that it says, yes, I found it in the cache, but you need to change the binding 0 to binding 1, and you need to change binding 1 to 0. After this mapping, I can immediately update it, but then I'm stuck with those bindings, because now I already told the GPU, please link this to that, fixing myself on those bindings. That should not be a problem, because they exist. I mean, we used them before. The descriptor set layouts just exist. But now I'm forced to use them in my pipeline layout, those descriptor set layouts. And I'm not 100% sure that that will always work. I suppose it should. Theoretically, theoretically it would be possible that I have a complete pipeline layout set using different descriptor set layouts. But then the question is, of course, how on earth would my engine ever have generated two different descriptor set layouts for the same layout? So once with the binding swapped. So in this case, let's say let's say this layout would already exist, so the mapping would be simply no change to identity. Then what I need is binding 1 for binding 1 for the texture and binding 0 for uniform buffer 1, which is not the same declaration as I used for the pipeline layout. So if then it's going to say, yes, the pipeline layout exists, but you need to do these translations, then I'm going to see, oh, but then I need to change my binding from 1 to 0 and from 0 to 1 here for set number 1. Which I cannot do. So it's definitely more flexible to delay the update of the bindings, but it's maybe not necessary. Now all that I was thinking while I was looking at this and saying nothing. I'm coming here, and then I think, okay, I have this. I'm trying to find my descriptor set layout, and then I find it or I do not find it, and if I find it, then the binding might be wrong. Shall I return a mapping, or shall I wait until I have the full pipeline layout? And then I think basically this. And you understand that normally I just do not give good explanations while I'm coding. That just takes way too long. It's slightly more complex than the bandwidth of chat allows to explain it continuously. Nevertheless, I still have to make this decision, and I have a feeling that delaying the update might be best, because I think it should work if I do it in steps. Yeah, well, maybe not. Well, how long have you been listening, Sunkelp? Have you listened to this story? The whole story? Or did you just enter? I think I can just use one binding and then one mapping, and then update the binding here, and then update the sets later, and I can at least detect if the bindings are always correct, and I think they should be. So I could use asserts to make sure that they are correct. Well, then you just missed a pretty rare real background explanation about what I'm doing at this very moment. Normally I'm just coding and nobody knows what I'm doing, I think. So yeah, I have a set binding mapping. I think I'm going to try to update that here, and then I'm just going to update the bindings, and then when finding a complete pipeline layout in the cache, I'll verify that the bindings are always correct, I think, and then only update the binding of the set numbers. No, I use C++20. It's necessary for that to have access to this binding map. So it's kind of I want to find it. Where is it? Something called with set binding. Might be characters before or after it. It's called set binding map. So here we have a set binding map. That's the only one I have. That's a local variable. It's not going to work. I need it here, and currently we are inside pipeline factory. I'm not sure. That's not going to work probably. So I need multiple set binding maps. One per pipeline layout, I guess. We're in the middle of a multi-loop, which gives me headaches to understand. We have a comment here. This is just multi-loop magic. These two lines result in having multiple for loops inside each other. Yeah, but it doesn't explain what those for loops are running over. So there's many for loops as there are characteristics. End, okay. Yeah, I have multiple characteristic ranges, theoretically. And each range is being iterated over. And then possibly I would get a different mapping for each case. So that's a lot of mappings. But the mapping starts here. I mean, I think inside initialize, so inside this call here, I'm doing this update. Or am I? It's a user code. Aniket, yeah. I have created a class called vector with a capital V, which is very dirty. Simply derived from standard vector, which is not allowed, they say, but well, kind of nonsense. It works. And the difference between the standard vector and my vector is that I changed the operator square brackets, and they're only allowed to use a special abstract index type, which is a wraparound size type. But different, you can have many different types. So then, say a certain vector has an index type, and you can only use that index type for the operator square brackets. And then also the add you can use it for. And then the iBegin returns the index type. So iBegin returns the index, returns 0 with the correct type. And iEnd returns the size with the correct index type. So if you run from iBegin till iEnd, you run over all the indexes that you can then plug into operator. Yeah, of course. I mean, the base class takes a size type. I can also cast it in my code, but casts are evil. So I should not use a cast in my own code, and then later complain that I'm using the wrong index type with the wrong vector. Okay, now you know what iBegin is. That's nice. Love from India. Well, I still have to use. I still have to make this decision what I'm going to do. So let me think for a bit. So this is the user code. And then at the end I do something that is called extremely dirty and dangerous, which calls this function, and that calls update descriptor set at the end. I totally agree, Aniket. All this stupid menus that continuously pop up to make it so that you don't have to type as much or something like that. It's just not necessary at all. What I do need or want, however, is a virtual reality thing, so 3 dimensions. I would like to stand in the middle of a virtual room that is empty except for a lot of glowing boxes that are connected with arrows, and then I can grab a box and move it around and enlarge it. I read text inside it and then code in that way. That would be cool. Sometimes my code gets so complicated that I really wish that I had I had a three-dimensional virtual space where I could organize my code in. I think I'm going to end the stream. It's dinner time, and I have some thinking to do anyway. I can think about this while I'm cooking and stuff like that. There's no need to sit here. It's probably even better. So, yeah, I might be back later or otherwise tomorrow. Probably later.